Pleasant day to everyone. Today we're going to discuss part 5 of Module 6, Fitting Curves and Interpolation. In this lecture, we are going to discuss interpolation formulas. So interpolation is defined as a type of estimating intermediate values between precise data points. It's a method of constructing or finding new data points based on the range of a discrete set of known data points. It's a procedure of data fitting which only requires a few points. There are different types of interpolation, and this would include linear interpolation, polynomial interpolation, and spline interpolation. The van der Moon matrix is used to identify interpolating polynomials. So before we start with our lecture, let us first have a review of data fitting or curve fitting. So when data points would form scattered plots in which a line or curve would only take the mean of points, data fitting is applied. And the first method under data fitting is what we call regression. This is used in cases when the number of points are given and the function or the equation is to be determined. The line would take, or the curve would take only the mean and would not intersect all the points in the given dataset. The second method of curve fitting is interpolation, wherein it is a more accurate method in drawing the trend as it passes all the points of the curve. There would be fewer data that would be required. And the last method is the Fourier series, wherein data points would create a periodic curve similar to a sine wave or any form that has repeated similar characteristics. In this lecture, we are going to focus on the second method, which is interpolation. So in interpolation, given a set of x and y, these values now would graph or plotted in a graph wherein 2 points would be connected by a line and more points could be defined by a curve. As defined, interpolation now is identifying the point within a curve or within a line. So in this graph, we have our maximum and minimum values or the boundaries of the line, x sub o and x sub n, and the value of xe can be interpolated using interpolation. And for the curve, we'll have now likewise x sub o and x sub n, which would define the boundary of the curve, and point x sub e will also be interpolated. A point x sub b is determined through extrapolation, which is defined as the process of determining a point within outside a curve or a line. Take note that for interpolation, the value of xe will be between the values of x sub o and x sub n, or the boundary values of x. While for x sub b, this will now be determined as or should follow the condition that x sub b should be greater than n and should be less than x sub o. The types of interpolation, the first one is the linear interpolation, which is applied for lines in which we have x sub o and x sub n as our boundaries, and point x sub a will be determined and would lie within the line connecting the 2 points. So given x sub o, x sub a, x sub n, y o, y e, and y n, We now apply similarities or ratio proportion, in which we have x sub o and x sub a with respect to yo, ye, will be equated to x sub o, xn, y sub o, yn, thus arriving at the general equation for linear interpolation. The next type of interpolation is the polynomial interpolation. So given a few points, we have a curve that would follow or pass through all the given points. This curve now is what we call your interpolating or interpolation curve, and the points x sub o, x sub n, and all other points passing through this curve is what we call your interpolation points or interpolation nodes. The interpolation of the given data set would be given by a specific polynomial in which it would pass through all the data points of the curve. The polynomial should consider the lowest possible degree, which is given by the equation, and what we call the interpolating polynomial. Another type, and the last type of interpolation, is spline interpolation, which is somewhat different to polynomial interpolation. This is an interpolation for a given data set, which is defined by a piecewise polynomial. The spline interpolation is preferred over polynomial interpolation due to smaller generated error. So in this lecture, we're going to focus on polynomial interpolation. There are different methods of approximating polynomial interpolation, and that would include Newton's divided difference formula, Lagrange interpolation formula, Gregory-Newton interpolation formula, Forward-Newton Gauss interpolation formula, and the Stirling's interpolation formula.